So in the last video, we saw how we can perform RAG with Langchain. So just for a quick recap, what RAG means is that whenever we have a LLM and we want to give it a prompt, let's say in this code that we wrote last time, we asked the LLM that do we have non-veg food in our hotel. So normal LLMs like ChatGPT or Gemini, who have not been trained on user specific data, can answer general questions, but they cannot answer questions that require specific context about your domain, about your business. So they can answer questions like what is the capital of France, etc., but they cannot tell any user if there is non-veg food available in your specific hotel. So for this, we learned a trick called RAG. So just to quickly summarize what RAG is, uh, whenever we ask, so if we are the user and we have a prompt, let us say the same, talk about whether we have non-veg options or not. So in our own hotel. So when we give this prompt to a LLM, we can't just give this prompt to the LLM, right? Because the LLM will not know about the options of food in our own hotel. So let us say we have a menu about our hotel as well. So if we somehow also give this menu to the LLM with our prompt, then it can answer the question. But the simple catch over here is in that in this particular case, giving a menu is enough. But what if there are a lot of other data about our business as well? Data about where or which all cities do we have our franchisees in? Data about what is our opening hours and etc. etc. There are a lot of documents. So let's say here we have the LLM. So we can't just give all of this data to LLM every time a user requests for a response, because that would cost us a lot of tokens. And not only that, we have a limit on the context window for any particular LLM. We can't just give it unlimited data for the context. So what we need is a system here in place in the middle, some type of a smart retrieval system which can, whenever we get a prompt from a user, get only the relevant documents from this field and then pass those relevant documents plus our prompt to the LLM, so that the LLM can have sufficient context to answer our question, but not too much context that we are overflowing the context window or using too many tokens. So an in-depth explanation of this and how this is achieved is available in the last video. So if you guys haven't watched that, you should go check that out. But in this video, what we are actually focusing on is that this is the code that we wrote last time. There is no changes in this code apart from just one thing, that we were using Google embeddings, but this time we are using Hugging Face embeddings so that we can just create the embeddings in our local and we don't have to do an API call for that. But other than that, everything is similar to the last video. But if you see, if I run this code right now, it will not run, because the time from then when the last video was made until now, Langchain has been developed a lot and a lot of libraries have been deprecated. So now there is no module named langchain.chains. So there is a way to make this work. So what they have done is that instead of this, you can import the same chains and the chains.combined documents and all these modules from langchain_classic instead of just langchain. So now if we run this code, it is taking a bit of a time because we are using local embeddings, so that takes a little bit of time to generate. But now as you can see, it says that no, we only have veg options, and this is the context that we are giving our model. So this is what we made in the last video. So we can also see that what was the source documents that were given. So we gave it 4 source documents from all these 6 available, and we also gave it a document which gives it data about whether we have wedge options or not. So now this code works. But this is the old way of doing RAG using Langchain. So this functionality has been moved to Langchain Classic for backward compatibility, but this is now not the recommended way to use RAG. So I will not explain what this code does, as you can just go and watch the previous video. In this video, what you are going to see is how to perform RAG in the new Langchain way. So now what has happened is Langchain has moved to a purely agentic type of architecture where it natively supports agent creation. So even for RAG, we can use agents and give our context to the agents just like we did in our retrieval QA chain in the last video. So for that, we first import the required libraries. So from chain.age agents import. So just typo import import. So create agent is the function that we use to create agents, and we will also import dot middleware dynamic prompt. So what are middlewares, you might ask? So middlewares are a way for us to interfere in the agent's flow of execution and run some custom code in some specific part. So for example, this is how the flow of execution goes inside a agentic AI call. So we have a request, then we have before agent, then we have before model, then there are tools, and there are models which we also can wrap inside hooks, and then there is after model and after agent. So all these are the parts where we can call our middlewares and perform some action to modify any particular part. So these hooks are especially useful when you're creating your custom middleware, but for now we are just using the inbuilt middleware called a dynamic prompt. So using this, what we'll be able to do is we'll be able to modify the prompt that goes to the NNM. So we'll just again import OS and import the .env. Actually, from .env we'll import the load.env and find.env. So these are just so that we can get our environment variables into the context when the program is running. This were explained in the previous video, so I'm not going to go too much into depth for these. And we can also just get all of these back as well. So we'll need the so let's move this last. So yeah, we'll need the Google Chat Generative AI for the LLM model. We'll need the Hugging Face embeddings over here as well, and we'll need the 5 RAG as well. But now we will not need the create retrieval chain or create stuff document chain, etc. So after this, what we'll do is first we'll also just like get the load.env over here, and setting up the vector store and the embeddings is also completely same. So we'll just set up the embeddings and the vector store. So we are using the Hugging Face embeddings with the all mini LMV L6 model, and we are just loading this hotel vector store local, which has all this data inside saved as vectors. So that also was explained in the previous video. And this allow dangerous deserialization is just so that because these are saved as pickle files and pickle files are not loaded, they are considered dangerous if you don't set this to true. And then we just create a retriever, which is just the vector store dot as retriever. So this retriever can now accept a query and it will return the most similar context documents for our queries. So now what we'll do, we'll just create a function called prompt with context. So the function could have had actually any name. So this will just have the request, but we are just calling it this, and what we'll do over here is we'll decorate this with this decorator dynamic prompt. So now we can use this as a middleware in our agentic execution flow. So in this, what we do is, first of all, we'll have to get the user's message. The message equal to, so you can get that from request.message messages, the last message we want, dot content. And then what we do is we need the docs, right? So retrieved docs equals to retriever.invoke. We'll invoke it with this message, and then we'll just create the context for our LLM. So context can be, we'll just let's say have some new line characters, and then join all the documents that were retrieved. So doc dot page content for doc in retrieved docs. So what we are doing here is just creating a string. So this context is nothing but a string which will have all the retrieved documents retrieved by this retriever joined with two new lines between them. So now we can create another new prompt, system prompt, which can be you are chat assistant for a 5-star hotel who talks in a very humorous way. So we can just add a lot of different stuff for some fun responses and answer the questions based on the context given. We can also tell it that if you don't know the answer, just say so. Don't make up answers. So we just added this so that we know if there is any problem in our retrieval pipeline, because if the context was not properly retrieved, the LLM will just say that it does not know the answer. So, and then we just give it the context, which can be just this context. And then what we do is we just return the system prompt. So now we have created a simple custom function that takes every message to the LLM and also adds some retrieved context from our vector store based on the query using our retriever. So creating the retriever and all are exactly as the same as we did in the previous video, but in this, instead of creating a QA retrieval chain, we are creating a custom function and decorating it with the decorator dynamic prompt, which is a type of a middleware. Don't worry, we'll dive deep into middlewares and how to use them, how to make custom middlewares in another video. For now, just understand that middlewares are something that lets us do specific actions in middle of the agent execution pipeline. So now we'll just create an agent. So you can say my agent equals to, we just use this create agent function that we imported, and we just have to give it the LLM in the middleware. So actually we did not create the LLM, so we'll also just do that right away. So we are just using the old code to create the Gemini 2.5 model. So we have added a API key for that in the .env file, and when we do this load .env and find .env, we load that into the context for this program. So that way you can just run this code and it makes a LLM that will respond to your queries based on the Gemini's free API key. So now we'll just give this model equals to our LLM and middleware. We also have to give this middleware, so we'll give this our custom function. So now we just invoke the agent the same way we invoke a normal chain in Langchain by the invoke method. So we just say my agent dot invoke, and we have to give it a messages type of object where we start with the human message. So and then we give this the query, so we can write the query over here. So the query can be do we have biscuits? So do we have biscuits? Do you have biscuits? So this is the query that we are giving, and this will be the response. And the result we can get from this response as .messa messages, the last one dot content. So messages is actually key in this dictionary, and then we just print the result. So let's first run this code and then we'll just summarize what we just did. So Python agentic RAG, we just forgot a comma. So as you can see, our model answers our questions. Biscuits, my dear, we have biscuits ranging from just a little treat all the way to I think I'll need a card for this one. Price from a humble ₹10 to a grand ₹50 every year. So yeah, this is talking in this way because we specifically asked it to talk in a very humorous way. But as you can see, it did answer the question correctly. So we have biscuits ranging from ₹10 to ₹50. So this is exactly the same result that we achieved in the previous RAG pipeline as well, but this time we did this using agents. And the specialty of this is that now you can, so now this agent not only has a special middleware to give it some extra context based on the queries, but it can also do a lot of other things that agents can do. Like you can give it tools to actually be able to interact with your system, which was not really possible for that retrieval QA chain, which was just designed for answering questions. So now you know how to use agents in Langchain and how to use RAG with those agents. So before finishing up, let's just quickly summarize what we did today. So in the last video, we learned about how to RAG using the retrieval QA chain, but since that has been deprecated, so not actually deprecated, but moved to Langchain Classic, and this is the new way to do the RAG in Langchain, we learned this. So what we did was we just created the embeddings, the vector store and the retriever just the way we did in the last video. We also just set up our LLM, but this time what we did was we just created a simple agent and we gave it a middleware, which was a custom function which we made, which got the user's request and retrieved some docs from our vector store based on the request, and then added that as a context to the prompt. And then we asked the LLM a very specific question which it would not be able to answer if it did not have the context about our specific hotel, and it was able to answer our question. So in the next video, we are going to learn more about agents in specific, and we'll also dive a little deep into middleware. So if you like this video, don't forget to subscribe so you don't miss out on any agentic AI updates, and thanks for watching.